Hi, and thanks for joining me. In this video, we are going to discuss thunderstorms. This video will deal with thunderstorm hazards. If you're interested in any of the other topics that you see on this slide, you can go to my YouTube channel and there are videos on those items. The hazard that we're going to discuss in this video is convective wind shear. Here are the topics that we'll discuss under convective wind shear. In this video, we'll start out with weather producers. The most common causes of convective wind shear are gust fronts, downbursts, and microbursts. The gust front is the leading edge of the outflow air coming from a thunderstorm. It could be a line of thunderstorms or just a single cell thunderstorm. But in particular, you'll have a change in wind direction across the gust front. As depicted here, it looks like a mini cold front, and the reason for that is because the air flowing out of a thunderstorm is cold air. Typically, that has been cooled by evaporation and also melting of precipitation as it falls. Another cause of wind shear is downburst, and downburst is just an area of strong, often damaging winds produced by one or more convective downdrafts over an area from less than 1 to up to 400 kilometers in horizontal dimensions. A downburst simply is the downdraft in a thunderstorm, and if that downdraft is very intense as it approaches the ground, it spreads out and diverges and produces a strong wind near the surface, and this is what we call a downburst. Downbursts are the general name for the downdraft and outflow from thunderstorms. Microbursts are a type of downburst. By definition, they're a convective downdraft or downburst that covers an area less than 4 kilometers or 2.5 miles along a side, with peak winds that last for anywhere from 2 to 5 minutes. So microbursts are smaller downbursts. If a small downburst has a wind change of more than 20 knots across the outflow, then we consider that a microburst. Microbursts have winds greater than 20 knots across. Microbursts also have a short duration, typically up to 25 minutes, but they can be much shorter than that. And also they can have a very strong intensity, producing winds that have been measured up to 168 miles an hour. So microbursts can further be subclassified into either wet or dry. Wet microbursts are ones where you have lots of precipitation at the surface, and typically these come from large thunderstorms. Other characteristics of wet microbursts, they have low cloud bases, heavy precipitation, usually develop in a humid atmosphere and have strong radar returns. So these are downdrafts and outflow from big thunderstorms over a very short, small area. Usually in a humid atmosphere, that means the temperature and dew point are very close together. And when that happens, that usually also implies that you have a very low cloud base. And of course, these are big thunderstorms, so you're going to see intense to extreme radar echoes. Whereas dry microbursts can be somewhat hard to identify because you don't see really large storms. You see just kind of towering cumulus developing in the area, or maybe even just smaller cumulus that could be precipitating. But as that precipitation falls, it evaporates. So dry microburst characteristics are you've got small rain showers, very high cloud bases because these develop in atmospheres that are rather dry. As I mentioned before, you don't get much precipitation at the surface. You usually get virga, but underneath that virga you get a strong downdraft and outflow. And then also, as I mentioned, dry atmosphere, so temperature dew point spread between 30 and 50 degrees Fahrenheit. That means if the temperature is 80, then the dew point would be somewhere around 40 or 30, so a dry atmosphere. And then also, these don't show up very well on radar. They may be just little green blotches, but you can very easily identify dry microbursts by looking at the virga that's associated with them as they're falling out. And when that virga hits the ground, or the downdraft hits the ground, you'll get blowing dust, strong winds and blowing dust if the surface is loose. Those are the more common producers of convective wind shear. If you're interested in convective wind shear, I have more videos at my YouTube channel.